Our today's question is to minimize the maximum difference of pairs. The question said you are given a zero-index integer array nums and an integer p. Find p pairs of indices of nums such that the maximum difference amongst all the pairs is minimized. Also ensure no index appears more than once amongst the p pairs. So the question itself is a bit confusing. I'll try my level best to explain it as much as the easiest way I can it possible. So at first, we all know what does the zero-indexed integer array means. Like the index will start from 0. So our first index will be 0, then 1, 2, 3, 4. That's how a array looks like. And all we have to find p value of pairs. For example, the p is 2 means we have to find 2 pairs, and among the 2 pairs we have to find maximum value, but this maximum value should be the minimum one. Means it have to be the minimum value among all of the pairs. But in these 2 pairs, or in this like 3, 4, 5 pairs, it have to be the maximum. But this maximum have to be the minimum one. The bit confusing. I'll try to explain it. Like copy this one, paste it here. So this is our array, right? And what can be the difference between the integers? One difference can be like difference between 10 and 1 is 9. There could be one difference between 7 and 1 is 6. There could be one more difference between 1 and 3 is 2. But if we use one index one time, we cannot use this index another time. So we have to find this kind of pairs, and we have to find the minimum difference of pairs. Minimum difference of pairs, and then we have to find the maximum value. So here, if we have a look at the question, we have to find 2 pairs here, and our 2 pairs will be one difference between 1 and 1, 0, and another pairs will be different between 2 and 3, and here the difference is 1. So we got one pair is 1 and 1, and the difference is 0. We get another pair is 2 and 3, the difference is 1. And among these two difference, the maximum value is 1. Our answer is 1. So if we have a look at the question, all we have to find the fifth minimum value, minimum difference. Means if the value of p is 3, we have to find the third minimum difference. Here the value of p is 2, we had to find the second minimum difference. So here is one trick. Now for finding the minimum difference, what we have to do, we can simply sort this array. Like if we sort this array, it looks like this: 1, 1, 2, 3, 7, and 10. And if I have a look the difference between 1 and 2, so our answer will be the second maximum difference, or second minimum difference. Now how can we find the fifth maximum difference, which should be the minimum one? If we simply have a look, our minimum difference will be 0. We can't go less than 0. At the same time, our maximum difference will be the difference between our last element and first element, which is 9 here. 10 minus 1, 9. So we can't go more than 9, and at the same time we can't go less than 10. Now if we set our left value 0 and right value 9, we can relate it to one technique, and which is our binary. So we'll do binary search here. So simply, what we'll do, we'll try to find our middle value here. So middle value will be 9 divided by 2 is 4. So what we'll do, we'll try to find the difference between the difference which is less than or equal to 4. And then if we find like pairs which is more than or equal to p-value, we will try to reduce our right value, which will be our middle value. And if we find the pairs is less than this one, we'll increase our left value and we'll run a while loop. So while left is less than right, and like when the left and right will be same, we can simply return the value of left or right. So what we'll do here, first the middle value will be 4, then we'll try to find the pairs. So if we have a look, the pairs now, the difference between 1 and 1 is 0, so we found one pairs. The difference between 2 and 3 is 1, we found another pairs. The difference between 7 and 10 is 3, we found another pairs. So we found 3 pairs, but we had to find the 2 pairs. So what we'll do, we'll like reduce the value of right. So now our left will be same, and right will be equal to our middle value, which is 4. Then our middle will be 4 divided by 2 is equal to 2. And now we will like run a for loop again, and we'll try to find the difference which is less than or equal to our middle value. So if we have a look again, this is 0, 1, so we found 1. This is the difference is 1, we found 2. Difference is 3, which is greater than our middle value. So we found 2 pairs here. So our value of 2 is value of p is 2. Now we will be more greedy. Okay, we found 2 pairs here, but what we will do, we will try more minimum one. Like what we will do, the left will be 0, we will reduce our right value. So right value will be equal to middle, which is 2. Then our middle will be 2 divided by 2 is 1. Again, we will have a look. So again, here is 0, the difference is 1, so we found 2. So again, we found 2 pairs, right? Now, what we will do, we will again reduce the value of right. L will be 0, right will be 1, and the middle will be 1 divided by 2 is 0. We will try to find the difference between pairs, which is less than equal to our middle value. So we found 1, and if we go there, this is the max, like the difference between 2 and 3 is 1, which is greater than our middle value. So we found only one pairs, which is less than our value of p. So in that case, we will increase the value of our left, and the value of our left will be middle plus 1. So middle is 0 plus 1 is 1, and value of right will remain same. So when the value of left and right will be same, we can say we found our answer. Our answer will be left value or right value. So we can simply return 1. That's it. Now if we implement this theory in our code, what I'll do, I'll find the size of array. And then what I have to do, I have to sort the array. And then what I'll do here, I'll take our left value, left is equal to 0, and right is equal to, the right will be the difference between our last element and first element. First element. So here it comes. Now we'll do a while loop while left is less than right. Right. Here we can find the middle value. Middle will be left minus left plus right minus left equal to. You can do like this as well, like and middle is equal to right plus left divided by 2. You can do this one, but I prefer the first one because sometimes the second one will give you integer overflow. Then we found our middle value. What we can do, we can analyze the pairs with 0, and we will run a for loop for I equal to start from 1, I less than n, I plus plus, and then if okay, so our current different, the current different will be nums of I minus nums of I minus 1. Here we will always get positive value as we already sorted the array. Means if we do minus from our previous index, we'll always get the positive value. Now if our middle value is greater than or equal our current different, means if the current different is low, then we found one pairs, right? And at the same time we can increase the value of I. Why I did increase the value of I here as well? Because now if we find one index here, one pair here, we have to increase the value of I by 2. So here it will be increased by 1, and when it will come from this if condition, it will increase the value of I will increase by 1 and again. And then so we'll go from for loop. If the pairs is greater than equal to p, what we will do? We'll reduce our value of right, else left is equal to mid plus 1, and then we can simply return our value of left. If we run this, why I did Paris here? Okay, so we got our answer, and I hope you understand this. So if I submit this one, so here I'll get one error because I didn't get any error, but what if the value of p is 0? What if the value of p is 0? Means we have to find like zero pairs. So if this is one edge case, if p is equal to 0, then we can simply return 0 from here. Now again, if I submit this one, yeah, I got it. Thank you.